Alright, so the other video didn't quite fit in the time I had thought of. So let's do another one quickly. So let's do something like f of x being 1 over x squared, centered at, I don't know, maybe a equals 1. Something like that. And see how we do. So let's start with taking our derivatives again. Well, first evaluate, f of a or f of 1. In this case, that's 1. So no problem there. Now I'm going to evaluate my derivative at 1. So the derivative of 1 over x squared is going to be negative 2 over x cubed, evaluated at x equals to 1. That's going to be negative 2. And then my second derivative is going to be evaluated at 1. Is going to be the derivative of this, which is going to be negative 3 times negative 2. That's going to be negative 3 because it's in the denominator, right? So negative 3 times negative 2, which is going to be positive 6 over x, and then add 1 to exponent in the denominator, which is subtracting 1 to the fourth, evaluated at x equals to 1. That's going to be positive 6. Third derivative, and I think after that we'll have an idea of what it should be. And when we evaluate it at 1, we will have that this is going to be negative 4 times 6 is negative 24 over x to the fifth at x equals to 1, which is going to be negative 24. Well, first we notice that there is an alternating sign. That's up front. Oops, I should say at 1. Well, whatever I wrote there, let me erase. So fn at 1. That's going to be equal to, well, we're going to have an alternating term. That's for sure. So negative 1, 2, and let's see what we have. So it's going to be positive at 0, negative at 1, positive at 2, negative at 3. So it seems like just n works, because n equals to 0 gives you positive 1, n equals to 1 gives you negative. Now notice what the terms we have. This is 1, this is 1 times 2, this one is 1 times 2 times 3, so it seems like we have n plus 1 factorial. Okay, if you don't believe me, pause right here and write a few of them. So for example, here, this would be 1, the first derivative. So 1 plus 1 is 2, 2 factorial is 2. 2 plus 1 is 3, 3 factorial is 6. And you can check that that's going to be our formula. Alright, so now let's take a look at what our Taylor series would look like. So it's going to be f of x should be equal to the sum from n equals 0 to infinity of negative 1 to the n times n plus 1 factorial over n factorial times, can I fit there? I think so, x minus 1 to the n. Barely, but I fit there. Alright, now notice that n plus 1 factorial over n factorial, n plus 1 factorial is n plus 1 times n factorial. So a lot of things are going to cancel, a lot of terms. You can end up with just the sum from n equals 0 to infinity of negative 1 to the n times n plus 1, that's the one that survives, times x minus 1 to the n. And that one is going to be a little bit disappointing, but I mean, that's what it is. So you grab your radius of convergence, you're going to try to compute it, and you're going to have that's going to be the limit as n goes to infinity of, and then you're going to grab this expression evaluated at n plus 1. So it's going to be n plus 2 plus 12. Okay, plus 2. Let's fix that. N plus 2 x minus 1, absolute value of that one, please, minus 1 to the n plus 1 over, this is easier to divide, n plus 1 x minus 1 to the n. All right, so what is going to cancel here? I'm going to cancel n of these guys with n, and I'm going to be left with just one of them. And the reason why this is a little bit of a letdown is because when you take your limit, well, you firstly pull out your absolute value, and you get this limit here, which is going to be 1. So not very exciting, but it is what it is. You can still get that this should be less than 1 by the ratio test, and that's going to be your radius of convergence. So the other letdown here is I ran out of space here, so I'm gonna have to erase here and write your interval of convergence real quick. So let me do that, and then we'll wrap this video up. So let me erase for 1 second. All right, so let's take a look at what our interval of convergence will be. Pick your center, A equals to 1, and your radius of convergence, positive 1. So you're going to move 1 unit to the right and 1 unit to the left. So you're going to have 1 and negative 1. So your interval, or your function if you will, you can write it as the sum from n equals 0 to infinity. Well, we wrote there negative 1 to the n times n plus 1 times x minus 1 to the n on the interval negative 1 minus 1 is negative 1 according to somebody here. Well, that should be a 0. Negative 0, 0. So, and plus 1, 1. I was centering it at 0 in my mind. That's what happened. Oh, wow. That's crazy. All right, so centering at 1 is going to be 1 to the left, 0. 1 to the right, 2. And that's going to be my interval of convergence. Now, I do still have to test the endpoints. However, notice that whenever you have either 0 or 1, you're going to have a series that does not go to 0 here. So it's going to diverge there. Nothing to test really. If I had a say over n plus 1, then at least on one endpoint I would have a conditional convergence. But in this case, it's just going to diverge at both endpoints. So that's going to be our interval, and that's going to be the expansion that we have. All right, guys, that's going to do it for this one. And I thank you for watching, and I'll see you the next time.